So this one is question 2 related to the rate of the cooling. It's the same thing what we just planned now. It's actually in terms of the experiment. So some students are investigating how the surrounding temperature affects the rate of a cooling at which the water cool down. They are using the apparatus as shown. A beaker A is there and a beaker B. And different temperature readings are there. You can use screen annotation to record the temperature theta A for a cold water in beaker A and warm water in beaker B. Like, what is this temperature reading? You can use the screen annotation to complete this. Don't forget to write the unit. So 18 degrees. Yeah, this one is 18 and the other one, that is 37. So 18 degrees and 37 degrees. Next, the test tube of a hot water is placed into a beaker A and B. Like what we did, we have a test tube of a hot water. It was there. Then we place it in the beaker. Like we place it here and then we place in a warm water. So there will be a difference in a temperature between the hot water and cold water. Here hot water and warm water, there will be a difference in temperature. The student records the temperature of water in a test tube for every 30 seconds. You can see the same pattern, like we recorded for 30 seconds interval. Complete the units in the table, complete the units and the time column. So first we have to complete the unit. You can use a screen annotation to complete the unit. So temperature, time is in second, that's right. You can use your mic or a chat. So this is a unit. Then we have to complete a time column. We are recording a temperature after every 30-second interval. So if this is 0, how much is this? What will be this one? 30. The next one?
30.
The next, 30. Next one? 60, 90, 120, 150, and 180. So it depends on the question. Some question they say we recorded the temperature after 1 minute. So it should be 60, then 120, then 180, then 240, and then 300. Depending on the question. This is right. Describe 2 precautions you would take before reading a thermometer to ensure that the thermometer readings are accurate as possible. We want to make
perpendicular to the scale.
Can you repeat? Sorry, I missed your point. What you said?
Look perpendicular to the scale.
Look perpendicular or look right angle. That's right. Or avoid a parallax error. Check. Avoid a parallax error. No, for thermometers, we cannot say we should make sure it is starting at 0. It can start with any number because thermometer usually record the surrounding temperature. So stopwatch, yes, it should be starting with 0, but thermometer, you cannot say like this. It is right. First point, we should mention avoid a parallax error. Look perpendicular. What else? So we should look perpendicular to avoid a parallax error. What other precaution we should take? for a reliable results, like for a thermometer reading. Normally, what happens whenever we read a thermometer reading, remember one thing, because there is a convection happen in a fluid or a liquid, and due to the convections, the temperature might not be same throughout. Maybe this region, the temperature is higher than this. They might be different. There is always a difference. So whenever we record a temperature of a mixture or a temperature of a hot water, we just stir the mixture. Thermometer bulb should not touch the base. That is one thing. Another thing, we should stir the mixture before recording a temperature. So you can mention stir before we record the temperature. And what else? There's another thing, as you mentioned, that thermometer bulb should not touch the base or the walls of a test tube. Why it should not touch the base or the walls of a test tube? Because the beaker temperature might be different from a liquid temperature. That's why. Not stir throughout the experiment. If you stir throughout the experiment, that will also affect the cooling. It will cool down. The moment, like example, we want to record a temperature after 30 seconds. So once we start the experiment, once we reach a 30-second interval, we just stir and then read the scale. That moment only, not stirring throughout. If you stir throughout the experiment, that will also affect the rate of the cooling. Then write a conclusion stating how increasing a temperature of a surrounding affects the rate of a cooling. Justify your answer by results in the table 1.1. This is table 1.1. How much it has cooled down in 180 seconds. So how you can work out the rate of the cooling? Rate is anything like changes with reference to time. So how much is the temperature change for beaker A?
So
Initial
minus final over time.
Initial minus final over time, or you can just compare. So this will be 51.5 degrees. What about this one? The temperature change for the second one. This is 51.5. What about this one? The other one? 81 to 45.5. How much is the temperature change?
35.5.
35.5. And if I want the rate of the cooling, like how much time, like how much they cool down every second. So what is the time interval? The time interval is 180. So if I want to work, you can mention this, that in 180 seconds, the temperature change for beaker A, which is having a low surrounding temperature, cool down or changes temperature by 51. Or for a beaker B, which is surrounding is warm or a high temperature, it cool down only by 35.5. Or if you want to say rate of a cooling of A, what will be the rate of cooling of A? Temperature change, which is 51.5 divided by, yes, you can better, it should be quantitative, not qualitative, like you should mention a quantity. So 51.5 divided by 180. What's the rate of cooling for A?
0.8 seconds.
51.5 divided by 180. 0.28, I guess. Yeah, 0.28.
Yes, 0.28.
0.28. 0.28 degrees centigrade per second. Like this much degree, the temperature changes every second. For beaker B, what is the rate of cooling? It was 35.5 is a temperature change in 180 seconds. So that's equal to 0.19. You can write 0.286 or even you can write 0.3. Both are acceptable, but in exam, write the answer in 3 significant figures. Whenever you're writing, 2 is fine, but 3 is best. So 0.19 degrees centigrade per second. So which beaker cooled down faster, beaker A or beaker B? So it is obvious that rate of cooling of beaker A is more. And why rate of cooling of beaker A is more? Because you can see the surrounding temperature. When we started, the surrounding temperature, it was a cold water. And the temperature of the cold water was 18 degrees. So surrounding temperature was 18 and the initial temperature was 80.5. So they have a greater difference in a temperature. That's why rate of cooling is faster. But for beaker B, the surrounding temperature, when we start the experiment, it was 37 and the initial temperature was 81. So the temperature difference is small. So that's why the rate of the cooling is slower. So rate of the cooling depends on the temperature difference between a hot water and or a temperature of an object and the surrounding temperature. So answer here, we will just mention our result like the rate of, because justify your answer by reference to the result. So you can say the rate of cooling of A equals to 0.28 degrees centigrade per second. And for B, that is equals to 0.19 degrees centigrade per centigrade. Or B cool down faster compared to A. And write a conclusion. So what we conclude the if there is a greater difference between the surrounding temperature, there is a greater rate of, like the rate of a cooling is higher or faster. Temperature of surrounding when greater difference between surrounding temperature and temperature of water. Yeah, A cools faster than B. That's right. You can mention that as well. But you have to justify with reading. Suggest one change to the experiment to ensure a fair comparison on effect of surrounding temperature on a cooling is a fair test. Explain why the change is an improvement, what change we'll do, and what explanation for that change. Like how we can make sure it's a fair comparison. There are many possible answers for this. Anyone want to use a chat? Or you can use your mic or a chat, it's up to you. For a fair comparison, you mentioned no insulation, it won't be accurate. Take equal volume of a water, that's true. Because rate of a cooling affected by, make sure there is no wind, because rate of cooling is affected by the wind. Make sure the temperature is same. The initial temperature is same, because why you cannot mention insulation? Because if you insulate the beaker, how the heat energy or transfer of heat energy can take place? If I insulate this beaker, if I insulate this test tube, then it won't be accurate. Because we want the heat energy to be lost to the surroundings so we can compare. We are already staring with a thermometer, like for a improvement, what we should do, you can mention different things like make sure you are using a same amount of the water, because rate of a cooling is affected by the amount of the liquid. You can mention same time interval, because rate of the cooling affected by the time interval as well. Same type of a beaker you should use, rate of a cooling is affected by the beaker. So the change is an improvement, like how we can improve this experiment. Measure the volume of water into a test tube or a beaker. Make sure like use same amount of the liquid. In the test tube and beaker, like we should, because the surrounding temperature and the explanation here, because the rate of the cooling changes with volume of the liquid. Then a student use a measuring cylinder to measure 200 cm cube of a cold water. Describe briefly how to read a measuring cylinder to obtain accurate value of the, and you may draw a diagram. So what we usually do, you will draw a measuring cylinder. We want to measure accurately 200 cm cube.
read lower meniscus.
So yeah, good. We will use always read the bottom of the meniscus and look perpendicular to avoid a parallax error. And read from the side of the scale, like marking. Like if the markings are on this left hand side and you're reading from the other side, so it won't be accurate. So these are the markings. Read the bottom of the meniscus, look perpendicular. Look perpendicular. To avoid a parallax error. So these are the things you should do. Can we mention place a lid since it is a heat loss by temperature difference? Yeah, lid is acceptable. So this was an experiment related to the factor which we investigate affecting the rate of the cooling. Like we are investigating how the temperature of a surrounding affects the rate of cooling. Is it clear? Any doubt in this?
No, sir, clear.